Hello everyone, welcome to a basic overview of CircuitJS. In this video, we're going to cover navigating the application, building and editing circuit elements, and view options to get more out of CircuitJS. As you can see in my browser, I have CircuitJS already open and running. I'm going to hit F11 to make that full screen. Starting in the top left, clicking the File tab will bring up options to load or save our circuits. They are saved as a simple text document and can be loaded by selecting this document or copying and pasting the text description. If I hit the File tab, you can see several options like Open File. If I hit this, it gives me the option to open a file up from my file browser for my computer system. I can also import a circuit from a text description. All I have to do is just type in the circuit description. It's in a text, and I hit OK, and CircuitJS draws up that circuit for us. Now obviously there's no circuit on the canvas because I didn't type anything into the description, and so CircuitJS assumes that it's a blank canvas. I also have the option to save this circuit that I have as a text file, and I can just hit that link and it downloads it for me. And lastly, I also have the option to export the circuit as text. This is the description of a circuit, and I can copy and paste this to any notepad or Word document. Next, we will look at the Circuits tab, which has many example circuits already created for us. For ECE 202, only the basics and AC circuits will be relevant. In the Options tab, we can change the current convention. This changes the apparent direction of current by assuming current is made up of negative electrons, which is real current, or positive particles, which is conventional current. If I hit the Options tab, you can see that it's already sets the conventional current motion. If I hit that, then it changes to non-conventional current, which is real current. Now we will cover drawing circuits. First off, let's start with a blank canvas by going to the Circuits tab and selecting blank circuit at the bottom. This erases anything that was previously on the canvas. I also have the option to select everything that's on the canvas using the shortcut Ctrl-A and hitting delete. As you guys can see on the left side of my screen, I have the keystrokes, and if you're not sure about what I just pressed, you can look at that. In the Draw tab, you can select the circuit element you wish to draw. Click and drag on the canvas to set the start and end points of the component. I click, and as you can see, I am drawing my wire. And to finish drawing my wire, I just release my mouse. And there you have it. That's the circuit component, a wire. If you make a mistake, you can undo the last change using Ctrl-Z or the option in the Edit tab. I go to the Edit tab and I can see it here, Ctrl-Z. Many of you are already familiar with this shortcut, so if I hit Ctrl-Z, it also does the undo function. And if I feel like I've gone back too far, I can go to the Edit tab again and hit Redo, or I can hit the Ctrl-Y shortcut. If you go back to the Draw tab, notice that common circuit elements have a letter beside them. You can press this button or this letter on the canvas to switch to that circuit component easily without having to go to the Draw tab. I'm just going to demonstrate. If I hit W, it selects a wire and I can draw a wire. If I hit R, it selects a resistor and I can draw a resistor. Now as time goes on, you guys will be more familiar with these shortcuts and you'll be more familiar with CircuitJS. Let's practice by building a simple circuit. I'm going to go ahead and go to Circuits and Blank Circuit. Select the voltage source by pressing V and place it. Another method is to go into the Draw tab, Inputs and Sources, Add Voltage Source. You click from your start point, you drag all the way onto your end point, and you release. And there's my voltage source. Now connect this voltage source to a resistor and complete the circuit with wires. To make this easier and faster, I'm going to start using shortcuts. If I hit R, my resistor, drop my resistor, W for wire, and complete the circuit with another wire. And there you have it, guys, our first simple circuit. If you wish to move the circuit element or change its endpoints, you can click and drag on them while holding the shift button. I'm holding the shift button, as you can see on the left, and I click and drag. And this allows me to move my circuit elements. This is very convenient and useful if you have to change the order of circuit elements. I can also use this function to change the length of my circuit elements as well. So I'm going to demonstrate this. If you want to change the length, just hold down the shift button, click and drag from the end point of any circuit element. And as you can see, I can make it longer or shorter, or change the direction. If your circuit is not working, make sure the circuit is closed and that the run or stop button in the top right is not red. For us, the run or stop button is not red, so our circuit is running. As you can see, there are tiny yellow particles moving through the circuit to signify current moving through the circuit. If I hit the run or stop button, it turns red, and as you can see, we don't have any yellow particles, yellow dots moving through the circuit. Another thing to know is that while your circuit is stopped, you can see here on the bottom that time is stopped as well. You can see that t equals 1.081 seconds when I stopped it, and if I run it again, time starts running, and of course our tiny yellow dots are moving through the circuit. Remember that CircuitJS only counts elements that share a start or end point as being connected. So you must use multiple small wires instead of connecting an element to the middle of the long one. To demonstrate this, I'm going to try and connect a resistor between this resistor and the voltage source. I hit R, and then if I try and draw a resistor between them, as you can see from the circuit, no current is flowing through this resistor. This is because this resistor does not share a start or end point with any of the wires or any of the other circuit elements, and thus CircuitJS does not recognize this. To fix this, all I have to do is connect the start and end points of this resistor to the start and end points of other circuit elements, preferably using small wires. I'm going to move this around. Select a wire, connect this wire to this resistor, then connect this resistor using a wire, connect them back to the voltage source, and there you have it. Our circuit is back running, and as you can see, there is also current flowing through this resistor. Now that we have a basic circuit, we can see how CircuitJS displays information. Hover over an element to display information about it in the bottom right. If I hover over this resistor, you can see the information displayed over here. So if I do that again, you see that it says resistor I equals to 5 MA, VD equals to 5 volts, R equals to 1 kilo ohms, and P equals to 25 MW. Those are just symbols for current, voltage, resistance, and power. If I go to this wire over here, you can see that it says wire I equals to 5 MA and V equals to 0 volts. This is just information concerning the circuit element. CircuitJS will always show the current passing through an element. One thing to note when drawing a voltage source is that you must ensure that you always draw the input source with the positive terminal above and the negative terminal below. Just like this, I'm going to demonstrate drawing a voltage source on our circuit right here. So I hit V for voltage source, and I click and drag from the bottom up. And that, guys, is how you draw your voltage source properly. If you're confused as to which is the positive terminal, note that the voltage source will always have two lines on top of one another, and the longer line will always signify the positive terminal. So this line over here that is above is longer than the other one, which signifies that this is the positive terminal, and this is on top, meaning that we've drawn our input source correctly. If you do not draw the input source with the positive terminal at the top, you will have a whole lot of problems with your wires saying 0 volts and having to swap terminals, which can get confusing. So always make sure the positive terminal is at the top. Right-click on one of the wires and select Edit to show the current and voltage across that wire. So I'm going to right-click, Edit, check both boxes, Show Current, Show Voltage, hit OK. And now you should see at the top of that wire 10 MA and 5 volts, signifying the current and voltage. I'll do the same for this wire as well. Right click, Edit, Show Current, Show Voltage, and hit OK. And now you can see 10 MA and 0 volts at the bottom wire. Another thing to note is that the top wire says 5 volts while the bottom wire says 0 volts, and you might be wondering why this is the case. The reason for this is because by positive current convention, the point where conventional current exits the input source is considered the point of maximum potential. So in our circuit over here, we can see that conventional current exits the input source at this point over here. So this will be considered our point of maximum potential. And in this circuit, we know that the highest potential or the maximum potential value is 5 volts. Hence why this wire says 5 volts. Inversely, the point where conventional current enters this input source is considered the point of minimum potential. So as we can see, while the current goes through this circuit and comes back into the input source at this point, this will be considered our point of minimum potential. And we also know that in this circuit, the smallest potential or the minimal potential value is 0 volts. Hence why this wire says 0 volts. Let us get a better view of the resistor by adding what we call scopes. We'll be adding 2 scopes to this resistor over here. But first, I'm just going to label this resistor. So if you want to add text to any of your circuits, drawings, or elements, just hit T and click on where you want the text to be. And you can see now you can edit the text. I'm going to edit this to say R1. So that is resistor R1. And now we are ready to draw our scopes. The first of the 2 scopes is a voltmeter, which is used to measure the voltage across an element. The next one is an ammeter, which is used to measure the current passing through an element. So to draw a voltmeter, go over to Draw. I'll put some labels. And over here you can see Add Voltmeter / Scope Probe. Click on that, And then what you want to do is go to the intersection of the wire and the resistor, click on that intersection and then drag. And as you can see, we are drawing our voltmeter. Later on, through the rest of the class, you'll be learning about that intersection and you'll be referring to it as a node, but that is not important for now. Now that we've added our voltmeter, let's go ahead and add our ammeter. We go back to draw, I'll put some labels and click on add ammeter. Now I would add an ammeter the same way I added a voltmeter and try and add it to the intersection. But as you can see, it does not measure anything. This is because our ammeter has to be added in series with the element. Now, what do I mean by series? When I say series, all I mean is that the ammeter must be added beside or next to the element in question. So I'm just going to get rid of this ammeter right here. I'm going to move this element around just so I can add the ammeter in series. Go back to draw, I'll put some labels, add ammeter, and now we can add our ammeter in series, and then I'll just connect the circuit again and we can see that the current is being measured. One thing to note about the ammeter is that when you're adding your ammeter, you must add the ammeter in the direction in which current is flowing. So if I remove this ammeter over here, you can see that there's an arrow on the ammeter that is pointing towards left. That arrow signifies the direction you should draw your ammeter in, and it also should correspond with the direction that current is flowing in. I'm going to put it back. If the arrow is not in the same direction as current, you're going to have a lot of issues with negative current, and you don't want to see that when you're drawing a circuit. So always ensure that your ammeter is pointing in the same direction that current is flowing in. Now that we have both the ammeter and the voltmeter, to see and visualize them better, let us view them both in scope. Right click on the ammeter and select view in scope. Do the same thing for the voltmeter, select view in scope. And on the bottom, you should see two graphs for the ammeter and the voltmeter respectively. If you highlight the ammeter graph, you should see in the bottom right that it says ammeter I is equal to 5 MA. That's just information about the current. And if you do the same thing for the voltmeter, you should see voltmeter VD is equal to 5V, which is again information about the voltage. The reason we have this is to visualize how current and voltage are affected in relation to resistance, a concept we will explore in the Ohm's law video. To change the value of resistance on a resistor, double click on it and you should see resistance ohms. You should be able to edit the component now. Go ahead and edit that to be 500. Hit OK, and now you can see that above the resistor it says 500, meaning we have changed the resistance. You should also have seen that the ammeter changed ever so slightly, and there was a slight increase in the current. The relationship we just witnessed with the ammeter and the resistance between increasing currents and decreasing resistance is a relationship we will explore in our Ohm's law video. We can also change values by using sliders. To add a slider to your input source or to the voltage source, right click on the voltage source and select sliders. Click voltage, and now you should see that you have an option to set the minimum value and the maximum value of your voltage source. Go ahead and edit that to be between 0 and 15. Hit OK. And on the right, you should see that you have a slider for your voltage source. You can use the slider to vary the voltage, and as I increase the slider, you can see that the voltage does increase. Just take a look at the voltmeter over here and also at the voltmeter scope. If I go ahead and decrease the slider, you can see that the voltmeter is changing and the graph is also changing. You can also add sliders for your resistance as well. Just do the same thing, right click on the resistor, click sliders, check the box that says resistance bracket ohms, and now you can see the same options that you had with your voltage source. Go ahead and edit the minimum value to 500 and the maximum you can leave as 1K. And on the right, once again, you should see a slider for your resistance. Increasing or decreasing the resistance slider, you can see that your resistance above resistor R1 is changing, increasing as I increase it on the slider and decreasing as I decrease it on the slider. Increasing and decreasing both sliders should have an effect on both scopes you see in the bottom. This relationship, like I mentioned previously, is what we will be exploring and trying to define in our Ohm's Law video. But for now, I highly recommend you play around with these sliders, move them around, and try and figure out that relationship for yourself. This, guys, was a simple tutorial on how to use CircuitJS, a tool we will be utilizing for circuit simulations throughout this course. Thanks so much for watching, and I'll see you in the Ohm's Law video.